We are starting Unit 6. Today we are in Lesson 6.1, multiplying and dividing decimals by powers of 10. You will need a calculator today, a whiteboard marker, and your math journal. So just make sure you have all these materials and pause the video if needed. I want you to write down the numbers 3, 5, 9, and 0, just as you see them. The first time around, I'm going to read the number for you, and I want you to determine where you're going to put the decimal point. Here we go. Write those numbers down, 3, 5, 9, 0. I would like you to put the decimal point so that this number reads 359. 359. Where did you put the decimal? 359. I didn't say in 0 tenths because guess what? If there are no tenths there, I wouldn't say anything. All right, I'd like you to write that number down, those numbers down again. 3590. I'm going to read another number for you. Listen to where the decimal point should be. 35 and 90 hundredths. 35 and 90 hundredths. 35 and, when I hear that decimal point, I hear the word and, 90 hundredths. All right, erase your whiteboard. Some more numbers to put down. 1, 0, 7, 4, 5, 6, 3. And then halfway down your whiteboard, you can write those numbers again. 1, 0, 7, 4, 5, 6, 3. I would like you to place the decimal point so your number reads 10,745 and 63 hundredths. 10,745 and 63 hundredths. 10,745 and 63 hundredths. Now let's take that same set of numerals and make your number say 107,456 and 3 tenths. 107,456 and 3 tenths. Say it one more time. 107,456 and 3 tenths. 107 thousandths. So when I write just 107, when I hear a word, I know there's a comma or a decimal point. 456 and 3 tenths. As I said earlier, today we're going to be learning how to multiply and divide decimals by powers of 10. Another way to write 3 and 2 tenths times 10 to the 6th power, another way is we could call this, here we have 3.2 or 3 and 2 tenths times 10 to the 6th power. Remember, exponential notation is where we're using an exponent. Base is the larger number that you are taking times itself, in this case 6 times. The exponent is the raised number, and the power of 10 is this whole thing where 10 is the base. Imagine we wanted to multiply a whole number like 3 by a power of 10. What rule have we used in previous lessons to multiply whole numbers by powers of 10? We know if we were to take a number like 3 times 10 to the 6th power, we know that we just take the 3 and we have 6 zeros behind it. Why does that rule make sense? Because each 0 that we attach or put on there shows we have multiplied by 10. So in this case, we'd multiply by 10, by 10, by 10, by 10, by 10, by 10, 6 times. Does attaching 6 zeros, if we were to take 3 2/10 times 10 to the 6th power, do you think if we just add 6 zeros behind that decimal, that would be correct? Well, the answer is no. And do you know why? Because this is a decimal and not a whole number. If I took 3 2/10 times 10 to the 6th power and just put 6 zeros behind it, 1, 2, 3, 4, 5, 6, my answer would be 32 million. And this is just a little bit larger than 3. So how could I go from 3 million to 32 million? It isn't the same when you're multiplying by a decimal. So today we're going to look for patterns and develop rules so that you know when you're multiplying or dividing by powers of 10 and have a decimal, what you need to do. So grab your calculator. What keys would you press to multiply 3 2/10 by 10 to the 6th power? Well, on my calculator, I would put in 3 2/10 with that decimal point, and then I would take it times 10 6 times. So I'm going to count out loud. You do it with me. Times 1 10, times 2 10, times 3 10s, times 4 10s, times 5 10s, times 6 10s. And here's the answer I get. $3,200,000. Why are there not 6 zeros behind there when I just multiplied it on my calculator? I'll tell you what happens. One of those 10s, when you have 3 2/10, the first 0 that you multiply, the first 10 that you multiply, moves the decimal point over one place to the right. Second 10, third 10, fourth 10, fifth 10, sixth 10. So each time you have to move the decimal point, it equals multiplying it by 10 because remember, it becomes 10 times greater. Let's go ahead and try this in our math journal. We're going to be on page 196. Page 196, and I do want you to have a calculator with you and use it. It says, when you multiply a number by a power of 10, do you expect the product or the answer when you multiply to be greater than or less than the start number, and why? Go ahead and write this down. It will be greater than what you start with. Multiplying by a number greater than 1 will give you a larger number. Number 2, use a calculator to complete the table. Look for patterns in how the decimal point moves. Note, you may need to place a 0 in the tens place to show the location of the decimal points for whole numbers. For example, write 453.0 instead of 453 to show the decimal. Okay, we're going to start with 4 and 5300. So put in 4.53 times 10 to the first means 110. So times 10 equals, and we're going to write that in standard notation. So 45 and 3/10. And the decimal moved one place to the right. So the movement of the decimal, the direction is right, and it moved one place. Now clear out your calculator and put in 4 and 5300ths again. 4.53 times 10 to the second means times 10 times 10. Times 110 times 210 equals, and the answer to that one, and this is where they want you to go ahead and put in 453 and 0/10. So the movement of the decimal point is to the right, and it moved 2 places. Clear out your calculator. Take 4.53 or 4 and 5300ths times 10 to the third. So count it out, times 110 times the second 10 times the third 10 equals 4,530. I'll write that again. 4,530. And it moved to the right, and it moved from here, 1, 2, 3. It moved 3 places. Clear out your calculator. Take in 4.53, 4 and 5300ths times 10 to the fourth. So count, times 110, times a second 10, times a third 10, times a fourth 10 equals 45,300. So how many places did it move? It was here. It moved 1, 2, 3, 4. So it moved to the right 4 places. What do you think is going to happen when you multiply by 10 to the 5th power? Well, let's try it. Take 4.53, 4 and 5300ths times 10 to the 5th. Count it out loud. Times 110, times 2 10s, times 3 10s, times 4 10s, times 5 10s equals 453,000 and 0 tenths. Move to the right. How many places did it move? Well, it was here. 1, 2, 3, 4, 5. It moved 5 places. So what's going to be the next one, everyone? Well, 4 and 5300ths times 10 to the 6th. You have to count out the tens. Times 110, 2 10s, 3 10s, 4 10s, 5 10s, 6 10s equals 44,530,000 and 0 tenths. Move to the right, and it moved. Again, it was here. Moved 1, 2, 3, 4, 5, 6 places. So look at the results in the table above. Compare the power of 10 in each row to the movement of the decimal point. What did you notice? Well, I noticed that the decimal point, write this down with me, the decimal point always moved or moves to the right. Based on the exponent in that power of 10. So use the pattern you noticed to write a rule for multiplying any decimal by a power of 10. So what you're going to do is move the decimal point. Now we're just talking about multiplying right now. Move the decimal point to the right based on the exponent. Same thing, right? So question 4 says if you divided a start number by a power of 10, would you expect the quotient or the answer to be greater than or less than the start number? It would be less than, because dividing by a number greater than 1 gives you an answer that's less than what you started with. So let's go ahead and try this out. Page 197. So now if we know that we move it to the right each time we multiply by a power of 10, we're going to do the opposite. So again, use your calculator. Start number is 67 and 2/10. 67.2 divided by 10 to the first power gives me 6 and 72/100. Do this with me. It moved to the left one place. So if we take and divide by 10 to the second power, let's clear out our calculator. 67, start with, and 2/10, divided by, remember we're doing 10 to the second power, so to divide by 10, 2 times. Divided by 10, 1 time, divided by 10 twice. I end up with 0.672. It moved to the left 2 places. So it was here, moved 1, 2. So let's do one more on the calculator, and then let's see if we can do the rest without a calculator. So let's take 67.2, 67 and 2/10, divided by 10 to the third power. So we have to divide by 10 3 times. Divided by 10 once, twice, 3 times. I end up with 0.672. So it started here. It moved 1, 2, 3. I even have to add a 0 there, so it moved to the left 3 places. Now, if I continue that same pattern, I just move it 4 places. 1, 2, 3, 1 more 4. So I'm going to add in 1 more 0. So it moved to the left. So it gets smaller as I move it to the left 4 places. 67 and 2/10 divided by 10 to the fifth is going to move 1, 2, 3, 4, 5. It moved to the left. How many spaces? 5. And lastly, for this table, 67 and 2/10 divided by 10 to the sixth power moves 1, 2, 3, 4, 5, 6. It moved to the left 6 places. So we're not going to write the next part, but what happened to the decimal point? It moved one place to the left for each exponent. Moved to this 2 places to the left, 3 places to the left, 4 places to the left, 5 places to the left, 6 places to the left. And let's end with this for today. Applying rules for multiplying and dividing by powers of 10. Remember, if you're multiplying, the decimal point moves to the right. If you are dividing, the decimal point moves to the left. Here we go. Use the rules you discovered to multiply and divide in problems 7 through 12. Do not use a calculator. You don't need one. So we're going to multiply by 10 to the second power. If I'm multiplying, the decimal point is going to go 2 places to the right. 1, 2. So I have to add a 0. 580. Number 8. I'm dividing, so my decimal point is going to the left once for each exponent. So 2 divided by 10 to the second power moves at 1, 2. Number 9, 673 and 9/10 divided by 10 to the second power moves 1, 2 places. So I have 6 and 739 thousandths. I'm multiplying in number 10, so it's going to go to the right. 1, and because there's no more place values, I have to add a 0. So 2,370. Number 11, I'm multiplying. 3 and 1/10 times 10 to the 4th, so I'm going to have to move it 4 places. So 1, 2, 3, 4. I have to put in 3 zeros. The answer would be 31,000. Number 12, I'm dividing, so my decimal point is going to move to the left 4 places. 1, 2, 3, and 1 more 4. This would be read tenths, hundredths, thousands, 10 thousandths, 100 thousandths. 492 hundred thousandths. That's it for today.